Welcome to the AI Tech Underground, where we dive deep into the fascinating world of video game graphics and uncover the inner workings of this captivating technology.
One enemy remaining.
In this video, we'll embark on an enlightening journey to understand the intricate processes that bring those stunning visuals to life on our screens. As we delve into the topic, prepare to be amazed by the sheer complexity and ingenuity behind the graphics that have captivated gamers for decades. From the early days of pixelated sprites to the breathtaking photorealism of modern games, the evolution of video game graphics has been nothing short of remarkable. We'll explore the foundations of this technology, the role of specialized hardware, and the rendering pipeline that transforms game data into the visuals we see on our screens. At the core of video game graphics lies a fundamental principle: the ability to render and display images on a screen. This process begins with the game engine, the powerful software that serves as the backbone of any video game. The game engine is responsible for managing the various elements that make up the game world, including the geometry, textures, lighting, and animations. As the player interacts with the game, the engine must continuously process and render these elements, ensuring that the visuals are updated in real time. This is where the magic happens. The engine utilizes a combination of hardware and software to transform the game's data into the stunning visuals we see on our screens. We'll delve deeper into the specific components and techniques that enable this remarkable feat of digital artistry. One of the key components in this process is the Graphics Processing Unit, or GPU. The GPU is a specialized piece of hardware that is designed to handle the heavy lifting of rendering graphics. Unlike the Central Processing Unit, CPU, which is responsible for general-purpose computing tasks, the GPU is optimized for the parallel processing of large amounts of data, making it the perfect tool for the job of video game graphics. The GPU's ability to process multiple data streams simultaneously allows it to handle the complex calculations required for rendering 3D environments, textures, and lighting effects. This parallel processing power is what enables video games to achieve the level of visual fidelity and smoothness that we've come to expect. We'll explore the inner workings of the GPU and how its specialized architecture contributes to the creation of stunning in-game visuals. At the heart of the GPU's graphics processing is the rendering pipeline, a series of stages that transform the game's data into the final image that appears on the screen. This pipeline typically consists of several key steps, including vertex processing, primitive assembly, rasterization, texture mapping, and lighting and shading. In the vertex processing stage, the GPU takes the 3D geometry of the game world and transforms it into a series of vertices, or points, in 3D space. These vertices are then processed and transformed to align with the game's camera and perspective. Next, the primitive assembly stage assembles these vertices into primitive shapes, such as triangles or polygons, which form the basic building blocks of the game's 3D environment. The rasterization stage is where the GPU takes these primitive shapes and converts them into a grid of pixels or picture elements that can be displayed on the screen. This process involves determining the color and shading of each pixel based on the properties of the primitive shapes. To add depth and realism to the game world, the GPU then applies textures to the primitive shapes, creating the illusion of detailed surfaces and materials. The final stage of the rendering pipeline involves the application of lighting and shading effects. The GPU calculates the way light interacts with the game's surfaces, creating shadows, reflections, and other visual effects that contribute to the overall realism and atmosphere of the game. This intricate process is what allows video game graphics to achieve such a high level of visual fidelity and immersion. As technology has advanced, the capabilities of video game graphics have grown exponentially. From the humble beginnings of 8-bit pixel art to the stunning photorealism of modern games, the journey of video game graphics has been nothing short of remarkable. In the early days of gaming, developers were limited by the hardware constraints of the time, leading to the creation of iconic pixel art and sprite-based visuals. As processing power and memory capacities increased, the industry was able to transition to 3D graphics, ushering in a new era of immersive game worlds and cinematic experiences. This evolution was driven by advancements in rendering techniques, such as the introduction of texture mapping, lighting, and shading algorithms. Today, the latest generation of consoles and high-end gaming PCs are capable of rendering breathtaking visuals that push the boundaries of what we thought possible. Ray tracing, a technique that simulates the realistic behavior of light, has revolutionized the way we perceive in-game environments, creating a level of realism that is truly awe-inspiring. Developers are now able to create virtual worlds that are indistinguishable from reality, blurring the line between the digital and the physical. As we look to the future, the potential for video game graphics is truly limitless. With the continued advancements in hardware, software, and rendering techniques, the gaming industry is poised to deliver even more stunning and immersive experiences. Emerging technologies like virtual reality and augmented reality are already transforming the way we interact with and experience video games. These new platforms offer the potential for even more immersive and realistic graphics as developers work to create virtual worlds that feel truly lifelike. Imagine being able to step into a game and feel as if you're truly part of the action, with every detail and texture within reach. Moreover, the rise of cloud gaming and the increasing power of streaming platforms are opening up new avenues for the delivery of high-quality graphics. As internet speeds and infrastructure continue to improve, the ability to render and stream complex game environments in real time will become more accessible to a wider audience. This could lead to a future where the hardware limitations of traditional gaming platforms are no longer a barrier, allowing for even more ambitious and visually stunning game experiences. As we've explored the inner workings of video game graphics, it's clear that this field is a testament to the incredible ingenuity and creativity of the gaming industry. From the humble beginnings of pixelated sprites to the breathtaking photorealism of today, the evolution of video game graphics has been a captivating journey. The advancements in rendering techniques, specialized hardware, and software have enabled developers to push the boundaries of what's possible in the digital realm. As we look to the future, the potential for even more immersive and realistic game experiences is truly exciting. Virtual reality, augmented reality, and cloud gaming are just a few of the emerging technologies that will shape the future of video game graphics. If you've enjoyed this deep dive into the world of video game graphics, be sure to subscribe to the AI Tech Underground for more fascinating insights into the cutting edge of technology. And don't forget to hit that like button. Your support helps us continue to bring you the best content on the internet. So what are you waiting for? Dive in and explore the ever-evolving world of video game graphics. The future is bright and the possibilities are endless. Join us as we continue to push the boundaries of what's possible in the world of digital entertainment.